Hello everyone. Today we will continue the section 1, areas under the curve. We will summarize the general case and then we will start section 4. Okay, we will start section 4. So we did the example 1, calculate the area under the parabola from 0 to 1. And we understand if we choose left end point and right end point, those rectangles will be different. Then we can use the area, the sum of the area from those approximating rectangles to estimate the area, right? To estimate the area of the region S. And that is one example. And we can prove with this limit, that is 1/3. Okay, that is 1/3. By the way, here is a typo actually. Here is a typo here. Okay, here is a typo. This part is not n plus 1 over n. It's 1 plus. Okay, it's 1 plus. Just a typo. Now, let's continue this part to summarize. If we have more general region S, which is under the function fx bounded by x-axis and two vertical lines x equals a, x equals b, how can we find the area of this region S? So the idea is we can use rectangles, right? We can use the a series of rectangles area to estimate, and we can increase the number of rectangles to make our estimation becomes more accurate in that way. Now, so the idea will be this region S, for this region S, we can divide it into n strips first. Okay, we can divide it into n strips, S1, S2, Si, Sm, and this is a curve from A to B, right? From A to B. Now again, we will do the equal weights for each strip. Then what is the length? What is the length for each strip? What is the weights? What is the weight for each strip? So that is what we did, okay? To find the areas under the more general region S, then we are going to divide the region S into n strips, right? Into n strips of the equal weights. So we got that the weights of the interval AB, okay, the general case. The weights of the general interval AB is B minus A, right? B minus A. So how about the weights for each strip? Here we have n, okay, we divided into n. This is a more general case we discussed, so we didn't specify the number of n. We have n strips. So here the weights for each strip will be B minus A over N, right? Each weights for the strip. Now we will call this one as delta X, okay? This is the important notation. We will talk about frequently. So that is the first step, okay? First step. The delta X will be the weights for each strip here. B minus A over N. Then let's discuss the interval, okay? Let's discuss the intervals. So these strips divided the interval AB into, we just call this is one interval, second interval, right? And in this way. So we can let my x0, I'm going to mark those points, okay? I'm going to mark those points. Let x0 equals a. So how can we calculate x1? How can we calculate x1? What is x1? So x1 here, of course, we can mark this one as x0, the left-hand point. So this is x0. What is the value for x1? We know the length is delta x, right? Delta x. So x1 will be a plus delta x. How about the x2? How about the x2? x2 will be a plus 2 times delta x. Or you can take it, x2 will be x1 plus delta x more, right? We have one more delta x based on x1. So based on this one, we have one more delta x. That is a plus 2 delta x. So x2 equals a plus 2 times delta x. Then how about xi? How about xi here? Here, xi. So xi will be a plus I times delta x. So we are going to mark those endpoints with the values, right? Then how about the last one? Here is xn minus 1. How about the b? So actually b will be our xn. Okay, b will be our xn. So we get all those endpoints. Now what are those subintervals? So those subintervals we can write in this way. The first one will be x0, the first subinterval, okay? The first subinterval, x0, x1. That is the first subinterval. And then x1 to x2, right? x1 to x2, second subinterval, and then the I subinterval. The I subinterval should be xi minus 1 to xi. xi minus 1 to xi. How about the last one? How about the n subinterval? N subinterval will be xn minus 1 to xn. Right? So we form those n subintervals, and if we look at the I subinterval, okay, if we look at the I subinterval, which one is the left endpoint of this interval? So this is the I subinterval. Of course, the left endpoint will be xi minus 1. The right endpoint will be xi, right? The reason we are talking about the left and the right endpoint is we are going to use the rectangle's area to estimate the each strips. So we are going to take the height of the rectangle. That depends on the either left endpoint we choose or right endpoint we choose. Make sense? That's why we mentioned, okay? That's why we mentioned the left and right endpoint for each interval. For example, the first one, okay, the first subinterval, x1 is the right endpoint. x1 is the right endpoint for the first interval, right? But x1 is, if you look at the second subinterval, here, then x1 becomes the left endpoint in that way, okay? Left interval. So be careful, okay? Be careful. Now we are going to estimate the area with the area of each strip SI with the rectangles, okay? With the rectangles. Let me check. Oh, okay. Today it works. Yesterday the color does not work. Okay, perfect. So I guess it will be more clear to illustrate this part today. Let me explain. We use the left endpoint or right endpoint to illustrate the. Now I zoom in the I strip. Okay. Now I zoom in the I strip. So this part is SI. The I strip. And then here, the left endpoint for the I strip will be xi minus 1, and the right endpoint is xi, right? Is xi. So if we use the left endpoint, okay, if we use the left endpoint, I will again keep the green color, okay? If we use the left endpoint, if we choose the left endpoint to form a rectangle, then to estimate the area of SI, this part. So if we use left endpoint, that means we choose xi minus 1. So we are going to take this height, right? this part, this value is f, this value is f x I, right? Sorry, f x I minus 1. So we are going to take this value as the height for the rectangle. That will be this green color. So if we choose the left-hand point to form a rectangle, then that will be this green rectangle. Then what is the area? What is the area for this rectangle? So will be the width, as will be the height, fxi minus 1 times delta x. What is delta x here? Weights, right? Equal weights. Each subinterval, the weights is the same, delta x, right? Delta x. So that is, we choose the left endpoint to form a rectangle to estimate the area of SI. Now, let's check the right endpoint. Okay, right endpoint. And actually, area of rectangle. Right? Let me just write more specific. Area of rectangle. So if we choose the right endpoint, which means xi, right? So we will take the function value at xi, which is this one, right? So here, this value will be fxi, right? This red one will be fxi. Then how can we form this rectangle with the right endpoint? So that is a larger one, right? So the rectangle, when we choose right endpoint, the area will be the height fxi times delta x, right? It's a little different with the height. Okay, it doesn't matter which one is smaller, which one is larger, because it's just an estimation, right? It's an estimation. We use rectangle to estimate the area of SI. We know the green one is a little smaller, the red one is a little larger, but it doesn't matter. Okay, so that is the case. Okay, so this is the case we choose the right endpoint. Now let's come back. Okay, now I think with different color, it's more clear to check the left and right endpoint. So here, if we look at this graph, okay, to estimate, this is the I strip, this is the I strip, and we took the function value. This is the I strip, and the subinterval, the I subinterval is xi minus 1. Left endpoint, xi is right endpoint. So the height we took for this rectangle is at the right endpoint. We take fxi as the height, right? As a height. Then fxi times delta x when we choose the right endpoint. So here, if you check every rectangle, how about the first one? First one here is fx1, right? This is the height. Here, this for the first rectangle, we took the height fx1, which is the function value at x1. And for the second one is fx2. What does this mean? So for each rectangle, to form each rectangle, actually this graph shows we choose right endpoint. Okay, we choose right endpoint to form the rectangle, and we are going to use the sum of all those rectangles to form the area, from the area to get the sum of all those rectangles area to estimate the area A. What is the capital A? A is the area of the region S. Now let's start. Okay, let's start to form the formula. So choosing, it's all we. In this case, okay, if you decide the right endpoint, it will be all go through right endpoint. If you choose left endpoint, it will be all go through the same way. Okay, choosing the right endpoint. Now let's form the choosing the right endpoint, then the area. Okay, the sum of n rectangles area. the sum of n rectangles area. I guess my handwriting improves a lot today. The sum of n rectangles area. Now, the area for the first rectangle, we know that, and all of those rectangles, their widths are the same, delta x, right? Delta x. And again, what is delta x? What is delta x if we have n subinterval? So this length, the whole width is b minus a, right? So delta x actually is b minus a over n, right? Then let's check the area for the first rectangle, okay? First rectangle will be fxi, which is the height, times delta x, width. Height times the width. And then what is the area of second rectangle? Of course, the height for the second rectangle, fx2 times the width. And how about the ice one choosing the right endpoint? We have already analyzed this part. So will be fxi times delta x again. All the weights are the same, okay? All the weights are the same. Then until the last one, what is the height for the last one? And be careful, we already said b is called xn, right? Xn. So will be fxn, the height, times delta x. Fxn times delta x, which gives the last rectangle's area, right? Last rectangle's area. So this is the sum of n rectangles, and we are going to use those areas to estimate the area. And actually those represent, choosing the right endpoint, we know the notation is Rn, right? If we choose the left endpoint, we call Ln with n rectangles, right? So we are much clear about those parts, okay? We're much clear about those parts. So here we have some analysis. So let us approximate the ice strip SI by a rectangle. Then how can we form this rectangle? The rectangle's area will be fxi times delta x. And then we can get our Rn in this way. So this Rn means using the right endpoint with n rectangles, right? With n rectangles. So Rn represents the sum, right? Rn represents the sum of n's rectangles. And actually, n rectangle is not enough. We will increase the number of n, okay? We will increase the number of n. So let's read this definition. The area A of the region S that lies under the graph of a continuous function f, we increase the number of n. What is the n we want to make the Rn get more close to the area A? We define as a limit. Okay, we define as a limit. And in the previous discussion, we said that if we increase the number of rectangles get larger and larger, the estimation will become more accurate, right? So this is the way we define the area A. If we let n goes to infinity, then the sum of those Rn, the limit of those Rn will equal to the area A. And this is the way we define the area A, and we can work out the area A. That's why we prove that in the example 1, this answer for the area A under the parabola from 0 to 1, this limit is 1/3. Then we know the area A is 1/3. So that is the definition for A. And we know that this is just the expansion of Rn. This is what does the Rn mean, right? What does Rn mean? And specifically here, actually we choose the Rn. We choose the right endpoint, right? And we mentioned that we can choose either left endpoint or right endpoint. And actually, besides those two, we have one more option, okay? We have one more option. And actually we can, let me just choose a yellow color. Actually, to estimate the area of SI, we can form a different rectangle. This green one is with left endpoint. This red one is with the right endpoint. Actually, for example, I can choose a value here. Be careful, I use a green color, okay? So I can choose any value here, just mean any value between xi minus 1 to xi in this I subinterval. I can choose any value, but I don't know right now, so I just use the star to represent. I just use the star to represent the any value we choose in the ith interval, okay? So here xi star means any value in the I subinterval, okay? In the I subinterval, what is the I subinterval? Xi minus 1 to xi. Any value we free choose, okay? Pick any value. Then if we pick this as xi star, then we form the height. So here, this one will be fxi star, okay? fxi star. Then we are going to form a new rectangle, which is in yellow color, okay? Which is in yellow color. What does xi represent? Someone asked the question. Xi means the endpoint. Just we mark the we mark all the endpoint for the n subinterval on the x-axis. We mark all those. So now we form a yellow rectangle. How can we form this yellow rectangle? We pick xi star, which is some value here, some value in the ith interval. We just free choose anyone, okay? Free choose one value. Then take the height at here. So this height will be the function value, the function fx evaluated at xi star. Okay, xi star. Then now if we choose this one, okay, if we choose this one, and actually we give a name of this star, this is called the sample point in the ith interval, okay, sample point in the ith interval. So those are green and right choice to form the area of the rectangles. Now the third option I wrote in the yellow color. So if we choose the sample point, what is the area of the rectangle? So the rectangle's area becomes fxi star, which means the function f evaluated at this value xi star. Then the width, of course, is the same, okay? And what does this mean if we choose the sample point? That means it becomes more general. You freely choose. And from here, actually, you will see that if you choose the left endpoint, the green color, the area is smaller, right? The area is smaller than SI. If you choose the right endpoint, you form the red rectangle. Of course, the red rectangle's area is greater than SI. But if you check the yellow color, it might be more accurate to get close to SI. And so this SI is more flexible, okay? Is more flexible to choose in the ith interval. As we said, xi can be any value. So xi can be left endpoint or right endpoint, or maybe can be the middle, okay? Can be the middle of xi minus 1 and xi, or some other values. So we just give a notation of this value. Xi star is called the sample point in the ith interval. So it will be more general to define the area A if we choose the sample point xi instead of the left endpoint and the right endpoint. Okay, so be careful to understand those graph I put in different colors. Okay, I put in different colors. So sample point, okay, sample point. That is the way we did in this graph. Okay, let's check this graph. So here in the first ith interval, we call x1 star. X1 star. So we pick a value, get very close to A, to the left endpoint. Then this one, okay? Then this one, for the first one, that forms the height. for the first rectangle, that forms the height. This height of the rectangle, that is fx1 star. Okay, fx1 star. Then the area for the first one should be fx1 star times delta x, right? And the second one, for the second rectangle, for the second strip, we form the second rectangle. Almost looks like x2 star is the middle point, right? It's in the middle of x1 and x2. So this height for the second rectangle, this is x2 star, right? x2 star, fx2 star, right? fx2 star, then times delta x, that forms the area for the second rectangle. Then that is the ice case, what we analyze is in the one blank board. I put in the yellow color, right? fxi star, the height for the ice rectangle, then times delta x. So we free choose xi star. And let's check how about the last one. The last one, we choose the xn star, which get a little close to the right endpoint xn. So the height will be fxn star. Then the area of the last rectangle will be fxn star times x. Okay, so this is not Rn again. This is more general choice. Okay, this is the more general choice. And Si, S1 star, X2 star, until Xi star, Xn star, they are called sample point for each subinterval. Okay, sample point in each subinterval. And we understand what is subinterval, right? Subinterval means you divided the interval a to b into n subintervals. The first interval is x0 to x1, second interval is x1 to x2, the I subinterval is xi minus 1 to xi. That is the subinterval we call. Okay, so that is the name. That is the we define those sample point. So why we talk about sample point? Because if we choose sample point, that will be more accurate, and especially the sample point can be left end point and also can be right end point. So just those two side end point is the special choice. Those are special choice of the sample point. Okay, so that is the way we define the area A. Okay, now let me repeat, what is area A again? That is the area of the region S, right? That is the focus, that is the topic we discussed in section 1, right? In section 1. I think I'm done with section 1 here. Yes. So now let's take a break, 5 minutes break, then we will continue the section 2. Okay? And just feel free to ask any questions.